All right, today, learning goal, we are going to use double angle identities to evaluate trig expressions and solve trig equations. So two different types of problems. So far on Friday and yesterday, what identities did we use? Seven different identities. Today we're looking at using double angle identities to evaluate trig expressions and to solve trig equations. I believe it takes 4 examples.
Yesterday you said 5.
Yesterday I said 5 and it took 4, but I think today is 4 and it takes 4. Alright, so double angle identities to evaluate trig expressions and solve trig equations. There are 5 double angle identities you need to write down, so write these down for me, please.
Is that 2 theta?
That is 2 theta. So now you can understand why it's called double angle. Because 2 times theta would be double theta, or double angle.
Oh, I got it.
Okay, notice that sine and tangent each just have 1, but cosine has 3 different ones. Okay, you can use any of the 3, but sometimes, depending on the situation, 1 is better than the other 2. But just realize that I can use any of those 3 I want. They will all give me the same answer. All right, everybody have it written down? Alright, so here's our first one. We're going to evaluate sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. And they're going to give me the information sine of theta equals negative 7 over 25. And theta is between pi and 3 pi over 2. So what are they telling me about theta if it's between pi and 3 pi over 2?
So it can be larger or smaller.
It's in the
Third
quadrant.
It's in the third quadrant. Okay, so this over here tells me that theta is in quadrant 3. Okay, so theta is in quadrant 3. So that's the information they give me. With that information, they want me to find those 3 things. So we're going to get started with sine of 2 theta. So what else do I want to write down to help me find sine of 2 theta? I want the formula. 2 sine of theta, cosine theta. Okay, when I evaluate this, I will have found what sine of 2 theta equals. Okay, and what do I already know that I can fill in for this? I know sine is negative 7 over 25. And I've got to figure out what cosine is. So what do I already know about cosine? What should I already be able to fill in about cosine?
Oh, it's 25.
The denominator is 25. How do I know that?
Because they're both hypotenuse.
Sine and cosine have the same denominator because they're both the hypotenuse. So I know that. Now I just need to figure out what the numerator is. So what am I going to do to figure out the numerator? Draw a triangle. So I've got 7. I've got 25. I'm going to use Pythagorean theorem to find this third side to save time. It ends up being 24. So So that means this is 24 over 25. But I also need to determine if it's positive or negative, and which one is it and why.
It's possible.
Because of the third quadrant. Because one's negative, so 4.
It is negative because my angle is in quadrant 3, and the only thing positive in quadrant 3 is tangent and cotangent. So that means this also has to be negative. So if we multiply that out, we figure out what sine of 2 theta is. 25 times 25 is 625. Did somebody know? Somebody multiply 2 times 7 times 24 for me. 2 times 7 times 24. How much? 336. And it ends up being positive, correct?
Yes.
Why? Negative times a negative. So I have found the first one. I found sine of 2 theta is 336 over 625. So now I'm ready to move on to cosine 2 theta. What's different about cosine? There's 3. So I want to be selective on which one I choose. Gage, look at those 3 and tell me which one I would like to choose in this case and then why. Which one would be most efficient? You have those 3 identities you wrote down just a second ago? Cosine 2 theta?
Mm-hmm.
There's 3 different ones. Which one would be the best one to use for this problem and why?
1 minus 2 sine squared,
That's an excellent choice. Why?
because we have sine, so we can then just square that.
Very good. Perfect. So I want to choose 1 minus 2 sine squared because they gave me sine. And all I have to do is plug it in and evaluate it. So I have 1 minus 2 times negative 7 over 25 squared. So I get 1 minus 2. If I square that, that's 49 over 625. If I multiply by 2, that's 98. So I have 1 minus 98 over 625. AJ, what does that end up being if I put those together? Or what do I need to do to find the final answer? All right, so what does that 1 turn into? 625 over 625. So what's 625 minus 98? Somebody.
527.
527? So I have found cosine. You can try, but it will not. And how do I know it will not simplify? All right, I didn't hear any answer I wanted to hear. What tells me that's not going to simplify? Besides just looking at the number. This over here tells me it's not going to simplify. How does this tell me? They have to have the same denominator. So that tells me this one has to be 625 and it's not going to simplify. Correct?
Yes.
Okay. Now, Lauren, what's the easiest way to find tangent of 2 theta now? Because there's 2 ways I can do it.
There's 2 ways.
There's 2 ways I can find tangent of 2 theta. What's one of them? Give me at least one. I can use the formula for tangent of 2 theta, which is 2 tangent theta over 1 minus 2, or 1 minus tangent squared. But, Christian, what's the easiest way?
This might sound difficult, but I was thinking of drawing a triangle.
We could draw a triangle, so there's actually 3 ways, but that's not the easiest way yet. Sky, what's the easiest way? There you go. Remember, tangent is just the numerator of sine over the numerator of cosine.
Oh my god.
Wait.
I was thinking. So-
That was what the point was.
So once I figure out what sine and cosine are, I can easily get tangent. Now, so we have evaluated sine of 2 theta, cosine of 2 theta, and tangent of 2 theta using our double angle identities. But we said theta was in quadrant 3. Why are all 3 of my answers positive?
Good question.
Because people usually get hung up on this. Why are all 3 of my answers positive when it said theta was in quadrant 3? Right, because are my answers dealing with theta? No, they're dealing with 2 theta. So if theta is in quadrant 3, is 2 theta going to be in quadrant 3? No, because it's going to be twice that. So this right here, this information only tells me what quadrant this stuff is in. Okay? Yeah, and as Kaylee said, what did you say? What quadrant is 2 theta in?
1.
It's in quadrant 1. How do you know that?
Because
Because I just do, it doesn't work.
she cheated.
The 0 and 2 there.
No. How do I know 2 theta is in quadrant 1? You don't know? Reagan, how do I know 2 theta is in quadrant 1?
Because 1 theta is in quadrant 3, so it's the same amount of.
I like the effort, but it doesn't work. Bree, how do I know it's in quadrant 1? You guys are thinking too hard.
They're all positive, therefore they.
Alright, Kurt's helping everybody out. All 3 of my sine, cosine, and tangent are positive. What's the only place all 3 of those are positive?
1.
Quadrant 1. That's what tells me I'm in quadrant 1. Let's try another one. Alright, this time they're giving me tangent. They're telling me my angle is between 3 pi over 2 and 2 pi. So calling where they're telling me my angle's at. Where's 3 pi over 2 at?
2 seconds.
What you do? You got 0, pi over 2, pi, 3 pi over 2. So 3 pi over 2 is here, and 2 pi is here. What quadrant's in between those two? 3 pi over 2, 2 pi. What quadrant is right here?
Others. It's all
3 pi over 2 is here, and 2 pi is here. What quadrant is this? What quadrant is that? 4! Alright. So we know our quadrant is 4. So let's start with sine again. So 2 sine of theta, cosine of theta. This time they didn't give me sine or cosine, they gave me tangent.
So you have to draw a triangle.
So I need a triangle. What do I already know about these two? What'd you say, Natasha? I know the numerators. What's the numerator of sine? 1. What's the numerator of cosine? 2. So I just need to figure out the denominators. Easiest way is to draw a triangle. So I've got 1 and 2. So the hypotenuse has to be square root of 5. Are either of those negative?
One.
One of them negative. Which one's negative? Sine is. Good. So I get -4 on the top. I get 5 on the bottom. So sine of 2 theta is -4/5. Now Gage did a great job of picking out which formula I wanted for cosine 2 theta on the last one. On this one, is there one that's better than the other? Bailey, you say no. Why?
Because none of the was given us tangent.
Right. Good. They gave me tangent. Tangent's not any of the cosine 2 theta. The one I liked is cosine 2 theta equals cosine squared minus sine squared. So I like that. Why do you think I like that one?
Because you know.
Yeah, because we just figured out what both of these are, and what's something I'm not going to have to do on this one that I had to do on the last one. What'd you say? Not really draw a triangle. What did I ask you to do on the last problem?
Yes.
Find the common denominator. Good. On this one, I don't have to, because they're already going to be the same. So 2 over the square root of 5 squared minus negative 1 over the square root of 5 squared. So that's going to give me 4/5 minus 1/5. So that means cosine 2 theta is 3/5.
That was easy.
So Blake,
Then we get it by ourselves.
what do I want to do to get tangent?
You want to numerator of sine of 2 theta over numerator of cosine 2 theta.
Very good. So we end up with negative 4/3. Alright, so that is using a double angle identity to evaluate trig expressions. Now we want to move on to solving trig equations. So we've got 2 of those.
Yeah, maybe it's this person.
We want to solve cosine 2 theta minus sine theta equals 0. What does that 0 to 2 pi tell me?
The quadrant.
No, we're solving. What does it tell me if I'm solving? I don't want all solutions, which means I'm not going to have
Plus 2
a
pi.
plus 2 pi in. Good.
I thought we were done.
So,
Yeah, it's
no.
Please be honest.
Alright. So if I'm going to use double angle identities to solve this, Kathleen, what do you suggest we do?
I kind of want to say isolate to like
what?
put sign on the other side.
Put sign on the other side?
Yeah.
Yeah, but I'm wanting what's the main thing I want to do first on this problem? If
Get
I'm going,
sign to 2 theta.
I
I
don't
have
want
no idea.
You have no idea.
I
Now
I
we're
don't
wanting
like
we're
this.
wanting to use double angle identities to solve this trig equation. So is there?
sub it out.
I want to substitute it out. Good. So I want to substitute this out. And then remember, how many does cosine 2 theta have, Rachel? 3. So I want to be specific about which one I choose. So which one of those 3, Rachel, would be the best one to use? All right, say that again.
1 minus 2 sine squared.
That is the correct one. Why do I want to use that one?
What?
Because I've got sine in the problem, so I want the one that has just sine. Very good.
So
All right, Lauren, now what do you suggest? So now it looks just like a problem we had on the last test. So what do you suggest now, Lauren?
Factor. Maybe.
What'd you say?
Factor.
Factor. What do I want to do before I factor? Before that.
Change the sign.
Those are the ones.
All right, everybody stop.
Oh my gosh.
Stop. Lauren,
Yes.
what did you suggest?
Do you want to like put it into like a different? I don't know.
You're on the right
You
track.
can do it.
Have some
Like
confidence.
turn it into like a binomial or something, or like make it like put the 1 over. You know what I'm saying? No. Like 2 sine squared theta minus sine theta minus 1.
All right, put it in the
Or
correct order is
plus
what I'm looking for. Good. Put it in the correct order.
Okay, thank you. We understood.
But I don't want my squared term to be negative,
So change the sign.
so change all my signs. So now we've got something we can factor. And I'm dealing with a trinomial. What does a trinomial always factor into?
Or shouldn't we slide and divide first?
We will, but what I'm wanting to know, what is a trinomial turned into? 2 binomials, thank you.
That's what I know.
Alright, so slide and divide. Gives me that. So I need factors of 2 subtracted to give me 1. Obviously, it's just going to be 2 and 1. What does that sign tell me? Different. This one tells me.
Biggest one's possible.
Very good. And don't forget to do what that you guys always forget.
Divide.
Divide.
Oh, that's when we sign up.
So we end up with sine plus 1 and 2 sine minus 1. Nick, what do we always want to do after we factor? 7 equal to 0. Good. So we get sine equals -1. I get sine equals 1/2. Say again. All right, Bobby. Sine equals -1. What does that give me? Or where do I need to look? Give me something.
Like the little, isn't it 3 times?
It is 3 pi over 2. How do I know it's 3 pi over 2?
You look at the graph and saw that a lot.
I'm looking at the graph, and I'm looking for
Order pair.
an order pair where, and which part of the order pair is sine? The y value. All right.
Whispers.
All right, Matthew. When does sine equal 1/2?
It equals 1/2 at pi divided by 6.
Pi over 6 is correct. This 1/2 is positive. So what 2 quadrants is sine positive in?
It is positive in quadrant 1 and also quadrant 2.
All right. How do I put an angle in quadrant 2?
Quadrant 2 is going to be 1 less than the denominator.
Very good. So we end up with pi over 2, pi over 6, or sorry, 3 pi over 2, pi over 6, and 5 pi over 6. So we use the double angle identity to solve that trig equation. One more.
Wait, so we don't put the plus 2 pi in, right?
Why not?
Because of that up there saying it's going to be between 0 and 2 pi.
Correct.
Okay.
Last one. I want to solve sine of 2x times cosecant of x equals 1. Sine of 2x times cosecant of x equals 1. I want to solve this using a double angle identity.
Would you treat x like theta?
Treat x just like theta, yes. Bobby,
If you convert cosine
we can convert cosecant to what?
1 over
Sine. And Christian, what else do I want to do? Since I'm wanting to use a double angle identity to solve this trig equation.
You subtract 1.
You heard what I said? We want to use a double angle identity to solve this trig equation.
Yeah. So you would sine 2 theta.
So I want to replace that with 2 sine of x, cosine of x. Tasha, what happens nicely for me here? The signs cancel. Good. When the signs cancel, I'm dealing with 2 cosine x equals 1. AJ, what's next?
Divide by 2.
Divide by 2. So cosine x equals 1/2. Reagan, when does cosine equal 1/2? Pi over 3. Very good. Kurt, the 1/2 is positive, so when is cosine positive?
First and fourth.
First and fourth. How do I put something in quadrant 4?
You times by 2 and subtract 1.
So we end up with pi over 3 and 5 pi over 3. Rachel, great question. When do we check?
Square.
If you have to square it. If I didn't square it, I don't have to check. Good question.
Will we ever square?
I don't want to say never. It's always possible. It's always in your arsenal.
Yeah.
Alright, so-
avoid that on the test?
No. We used double angle identities to evaluate trig expressions on our first two examples, and then we used it to solve trig equations on our second two examples. Alright, your assignment is page 352, 2 to 14 even.
Okay, 7.